what's going on everyone? This is BekBrace channel. My name is Amir. Welcome to the Go programming language full course for beginners. In this course, I've put all of my effort into teaching you everything you need to know, explaining the core concepts and the principles that make Go a powerful language so you can start programming in no time. And before we get started, I hope you're finding these tutorials and courses helpful because I love creating these resources and sharing them with you all for free. If you have found value in my work and would like to help keep this content accessible for everyone, you can consider subscribing to my channel, or you can even take it one step further and consider being a member of the channel. Eventually, you can join our community on Patreon, or simply you can buy me a coffee to keep me fueled. Thank you so much for being part of our learning community. And with that out of the way, let's go ahead and start our course. So first of all, what is Go? Go, also known as Golang, is a statically typed compiled programming language designed by Google. Go language was created by Robert Grismer, Rob Pike, and Ken Thompson. And of course, when I knew that the Ken Thompson was one of the co-creators of the Go programming language, that was the deal breaker for me. I rushed and I learned Go language very quickly. For those of you who don't know who is Ken Thompson is a legendary computer scientist known for co-founding the Unix operating system, which was co-created, by the way, with Dennis Ritchie in 1969 at Bell Labs. If we're honest, this is quite a milestone in computer history. Ken Thompson also wrote the B programming language, which was a stripped-down version of the BCPL, the Basic Combined Programming Language, created and designed by Martin Richards in 1952. So the contribution of Ken Thompson in the field of computer science is endless. He has contributed significantly to the development of computing as we know it today. It's worth noting here that Ken Thompson and Dennis Ritchie have received the National Medal of Technology from President Bill Clinton in 1999. And this prestigious award was given in recognition of their significant contributions to the development of the Unix operating system. I'm going to give you a little bit of the history. What happened here is that the Unix at the time was written in assembly language, and we had a lot of Unix versions based on each machine. Each machine had its own architecture. Ken Thompson and Dennis Ritchie have rewritten the whole Unix operating system in the C language. This way they had only one code base for Unix instead of having different Unix versions based on different assembly code that work on different machine architectures. So sorry for the distraction here, but when I talk about Ken Thompson, I can't stop. Ken Thompson for me is one of the greatest computer scientists ever lived on planet Earth. And together with two great computer scientists like Rob Pike and Robert Grismer, they have created together the Go programming language, and they're all working at Google. Alright, let's talk a little bit about the history and development of Go language. So Go was conceived in 2007 at Google as a solution to improve programming productivity in an era of multi-core processors, networked systems, and large code bases. The designers aimed to create a language that combined the performance and security benefits of statically typed languages like C++ with the speed of dynamic languages like Python. And in 2009, Google publicly announced Go as an open source project. And in 2012, the first stable version, Go 1.0, was released. Now let's discuss a little bit the community and popularity of Go programming language. So Go has gained significant traction in the developer community for its simplicity, performance, and efficient concurrency model. And according to the Stack Overflow developer survey, Go is consistently ranked among the most loved programming languages. In recent years, more than 60% of developers who have used Go expressed a desire to continue using it. Go is praised for its simplicity with a clean and concise syntax that reduces the learning curve for beginners while being powerful enough for seasoned developers. And we're going to get back to the point of simplicity because I remember that Ken Thompson himself said that one of the main pillars of creating the Go programming language was simplicity and minimalism. So they wanted Go to act like C language but simpler. They sometimes even refer to Go as the C language for the 21st century. And you can see on the screen the highest salary for Go programming language is $92,760. That's actually the 10th position after Zig, Erlang, F#, Ruby, and so on. This is actually higher than the Rust programmers for $87,000 and the Python programmers for $78,000. And you can see that there are a lot of companies that heavily depend on Go. Google, number one, of course, the founder of Go language, PayPal, American Express, Meta, Twitch, Cloudflare. There are a lot of companies and organizations that are not mentioned here that depend heavily on Go to create their software and services. So you can see here it says at the time no single team member knew Go, but within a month everyone was writing in Go. And that's the beauty of the Go language. It's a very simple and easy language to catch if you're familiar with other programming language or C-based programming language like JavaScript, Java, C++, C#, and all of that. But even if you're not familiar with any of those languages, that doesn't matter. Go is a very simple language to catch, and the syntax makes perfect sense even for beginners. So last words before I go, no pun intended, and install Go on my local machine. Why choose Go language? First off, concurrency. So Go provides built-in support for concurrent programming using Go routines and channels. And that makes it easy to write concurrent programs. For those of you who write concurrent programs, know actually how difficult it is to write concurrent programs, multi-core threads, and all of that. The second key feature is simplicity. Go has a clean and concise syntax, which makes it easy to read and write code. And as I told you, Ken Thompson had minimalism and simplicity in mind when he was co-creating the Go language. Also performance. So Go is a compiled language, right? That means that it offers high performance similar to C and C++. Also garbage collection. To some languages, this is a bug and not a feature. So Go includes automatic memory management and garbage collection. In Rust, automatic memory management is not considered to be a feature, but rather a bug. It creates a lot of errors and bugs such as dangling errors or data races. And finally, the beautiful thing about Go language that it is a statically typed language. So Go is statically typed language like C, Java, Rust, TypeScript, and this is great because it helps catching the errors at compile time. So final thoughts about why you should choose Go as your programming language for development. Go aims to be a modern, fast language that makes it easier to develop reliable and efficient software. And you've seen yourself how many organizations and companies depend on Go in their software. They all use Go language in production, and that speaks to its reliability and performance. Alright guys, so this is the end of the introduction. In the next part, we're going to see how to install Go and start coding our first Hello World program. Thank you so much for watching, and I will see you shortly in the next one. Hello guys, and welcome back. To start programming in Go, we need to install Go on our computer. And as I'm operating on Microsoft Windows, I'm going to show you the exact steps and what you need to do if you're operating on Windows like me. So I'm going to type go.dev, that's the website for Go language, with this cute little gopher, the mascot of Go. And it tells you here, build simple, secure, scalable systems with Go. This is an open source programming language supported by Google. It's easy to learn and great for teams, built-in concurrency and robust standard library and large ecosystem of partners, communities, and tools. You can get started by learning here, download packages for Windows 64, Mac OS, Linux, and more. The company is using Go, this you have seen in the last video. You can try Go directly, so Go has something called the playground, where you can type your code and you can run it. So it's going to compile online. So if you will click on run, it was already, okay, displayed hello and that Chinese or Japanese name, I don't know. You can share that, you can click on tour. So tour is awesome because it's going to take you to this tour of Go where you're going to learn in practice. So you're going to type your code here, can delete all of that if you want, and you can run. So you can change that. Hello Amir, you can click on run. Hello Amir. This is a simple Hello World program that we're going to see in the next video, and so on and so forth. So you can choose the language that you want. Go offline. So if you're offline, the Go documentation will continue to be working. This will place a tour binary in your Go path, and we're going to talk that in a bit. And just down here below, you will find that what's possible to create with Go. So you can create command line interface applications, web dev, cloud and network services, and this is because of the powerful and efficient coroutine model in Go. Down here also you can do DevOps and site reliability. You can check out more use cases if you want. Get started with Go, you can click get started, that's the same button at the top. And again, you can click here on tour, that's going to take you to the same page where we were before. And of course you have the Google label because of course Go was created at Google, right? You can connect through Twitter, GitHub, Slack, or Golang. If you'll click on that, you find here that this is Reddit. And you can see the forums, people talking about Go. You will share your experience and knowledge with different programmers who are interested in Go. So now let's go ahead and download Go on our machine. So I'm going to click on download, and that's going to take me to this page. And the stable version is Go 1.22.4, and that's the one that we're going to install. So I'm going to click on the Microsoft installer here, save that. All right, that's downloaded. If you'll double click on that, and I'm not going to install it because I have it already installed, but all what you need to do is to click next, 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 and that's going to be installed on your local machine. Once that's installed and you're satisfied with the results, you can open your terminal and you'll type here Go version, right? That's 1.22.3. All right, and the one we have on the website, the stable release or the stable version is 1.22.4. That's not a big deal. This has been recently added. And one more important thing, guys, you need to verify that you have the Go path in your environment variables. So I'm going to type environment variables. So you will have this system properties, and down here below, you will click on environment variables and take a look at that. Go path as a variable, and the value is the path itself. So in the C directory, the users folder, and whatever your name is, my name is Amir, so that's going to be inside Amir, and inside Amir there is Go. So make sure you have this well set in your environment variables. If not, you will need to click on New, and in variable name you will need to type Go path, and the variable value that should be this way: the C directory, the users folder, your name, and then Go. All right, once you have that set, if you will type Go here, you should see this, right? That's the help menu, guys. Go is a tool for managing Go source code. Okay, so usage, so you have here different commands, you have different flags, right? So for example, if you want to have a bug report, you would do Go bug. If you want to compile the packages and dependencies for your project, you would do Go build. Go clean, you're going to clean all of the cached files from your project, doc for documentation, env to print the Go environment information, and so on. Right, so that's it basically, guys, for this video. In the next video, we're going to see how we can write our first Hello World program. Thank you so much for watching, and I will see you shortly in the next one. Hello guys, and welcome back. In this video, we're going to write our first Hello World program. And as you can see here on the left side, I have all of the folders related to our course. So we're actually here, number 2, basic syntax, and I'm going to add a simple file. Now the file, I'm going to call it main, and the extension for the Go language is of course Go. And now we are ready to write our first Hello World program. Now, writing a program in Go is different than if you would do it in any other programming language. Every Go file should start with a package declaration. So packages are Go's way of organizing and reusing code. Now, the way to do that is by typing package main. I'm going just to snooze the tab 9 for 1 hour. That's the first thing you need to do in any Go file that you will write. The main package here is very special. It defines a standalone executable program and not a library. So once you've declared your main package, you are ready now to import. So that's the first thing you need to do in any Go program. So that's here, package declaration, right? The next thing you need to do is to import different packages. So for example, one very important package that you almost import in any Go program is the format package. So the format package, you can import it like this, import FMT. This line here imports the format package that contains functions for formatted input-output operations. Things like scan format or scanf, printf, println, and a lot of other functions that you can import from this format package. Now, do not be confused and think that you are importing the format from the main. No, the main is a package on its own and the format is a package on its own. Now, to define a function in Go, you will use the keyword func. That's similar to fn in Rust, def in Python, function in JavaScript, and so on, right? So by func, you are defining a function. Now, the main of the main function, of course, is main. Following that, parentheses, open close paren, and curly braces. Inside your curly braces here, this block, you're free to write your local code. And by local, I mean that you can write or you can define variables here in the global scope, but locally inside the main scope here, you're free to write all of the code that you want. Right, so the first thing that I want to show you is how to write a comment. So to write a comment, simply you will type /. It's the same thing that you would do in JavaScript, for example. So this is a single line comment. Writing multi-line comments is done by doing /***. And here you will type, this is a multi-line comment. Now I want to print the hello world to the console. The way to do that is very simple. Now remember when we said that we need this format package to use it in order to access different functions. That's exactly what we're going to do now. So I'm going to take the format package and I will access this beautiful function called println. Now be careful that print starts by P capitalized. Then what you would do usually in any other programming language, you will open parentheses, you will open double quotes, and you will say hello world. So like C, Go is a semicolon type of language. You can add your semicolon or you can ignore your semicolon. Either way, the code is going to compile just fine. Alright, so let me open my integrated terminal now. So to compile your file in Go, you will start by saying Go, following that a command called build. So you're going to build from your Go file an executable file. So you need to create an output file, right? That's why we need the O flag. Following this is going to be the last argument, which is going to be the name of our executable file. You can call it anything. It's not necessarily to be exactly the same name of your Go file. You can say hello, for example, but for consistency reasons, I'm going to keep it as main. Now, main should be followed by the extension of the file. As we said, this is an executable file, so that's going to be followed by .exe. Hit enter. And there we go, our program has compiled successfully. If you will list the components of the file, let me just minimize this a little bit. We have created a new file called main.exe. Eventually, you're going to need to create a module file. Now, a module file is very similar to package.json in Node.js or cargo.toml in your Rust program. So this module file simply is going to track all of the packages and dependencies that you're going to install in your project. And to create that file, simply you would do go mod init, and you will call that file whatever you want to call it. So I'm going to keep it consistent and call it main. Now it tells you here that creating new go.mod module main. Now, if you will list the components of your project again, you will find that you have here a new file called go.mod. And let's check it out. If I will click on go.mod, you will find clearly that we have here our main module with the Go language version, right? So whenever you're going to install any third-party library, package, dependency, whatever, that's all going to be tracked here. As I told you, this is very similar to package.json in your Node project or your cargo.toml in your Rust project. All right, so let's get back to our integrated terminal. Let me close the Explorer and let's run our main file. So the way to run your executable is by typing ./main.exe. Hit enter and you have here your hello world printed to your console. All right, guys, so that's it. This was how to print a simple hello world to your console in Go programming language. So thank you so much, guys, for watching, and I will see you in the next lesson where we're going to study the primitive and compound data types. Hello and welcome back. In this lesson, we are going to study the primitive data types in Go. So the primitive data types in Go language include integers, floating points, booleans, complex numbers, and strings. So I'm going to give you a quick example on each and every one of them so you would understand how we can work with those data types. So the first thing that I will need to do, of course, as always, is to import the main package. Right? So this main package tells Go that this is an executable program and not a shared library. Also, I will need to import the format package. This package provides functions to output data to the console. As you have seen the last time when we have printed the hello world, we have used the format package and we have accessed the function called println, and we have printed whatever that we wanted to print. In that case, it was hello world. So I need now to create the main function, right? And inside that curly braces, I will need to enter my code here. So I'm going to divide this tutorial into different sections, and each section is going to comprise one data type, one specific data type. I'm going to start by the integers. So section 1, that's going to be for the integers. So in Go, as in a lot of programming languages, integers could be signed or unsigned. Signed integer means that the integer itself or the number itself could be positive or negative, doesn't matter. However, unsigned integers should always be positive. So that's going to be section 1a, signed integers. Right, so to declare a variable in Go, you can use the keyword var. We're going to see that in details in the next lesson, where we're going to study the variables in Go. But for now, you can use the keyword var to declare a variable. I'm going to declare a variable, I'm going to call it I, and that's going to be of data type int. Int is the data type for integer, and the size depends on the platform, whether 32 or 64 bits. We can have few more. So we can have the I8, we can have the I16, we can have the 32, and we can have the 64. So we don't need that. All right, and of course we're going to change the data type themselves. So we have int 8, 16, 32, and 64. So all these are signed integers. This is of 8-bit, 16-bit, 32-bit, and 64-bit. Here, what you have done is you have just only declared the variable. That's it. You haven't actually assigned to that variable any values. To assign a value to that variable, you will need to do it on a separate line. So the I is going to be -128 because that's signed. That could be positive or negative. Similarly for the 8-bit integer, 127, I16, I32, and I64, that's the largest. And we can do exactly the same thing for the unsigned. So I'm going to change that simply here. That's going to be B, and that's going to be unsigned integers. And instead of the I, I'm going to change that to U. This one here is the default unsigned integer type, and the size depends again on the platform, whether 32 or 64. And that's going to be U int instead of int. However, the values, guys, for those variables, U, U8, U16, U32, and U64, have to be only positive. Now let's print the values of the integer variables to the console. So I'm going to use the format package.println, open parentheses, and I will say here signed integers, and exactly the same thing for the unsigned integers. So let's go ahead and compile our code. To compile the code, you will need to create an executable like we've seen last time in our hello world. So we do go build, and we need an output file. I'm gonna call that main.exe. All right, awesome. Now, if you will check out the components, you will find here that you have main.go and main.exe. So go ahead and run your executable, and there you go. You have your signed integers and unsigned integers. So these are the integers that exist in Go language. Let's move on and check out other data type. So we'll say here section 2, the floating point. So floating point types represent numbers with a fractional part. I think all of you guys understand what is a floating point. So Go provides actually two different floating point types, the float32 and the float64. So again, I'm going to use the keyword var, and I'm going to create a variable or declare a variable called f32, and the data type is float32. Okay, and that's going to be equal to 10.6, for example. Now, you need to keep in mind that float32 is used for less precise calculations, and on the contrary, this is used for more precise calculations. All right, so I'm going to show you that in a minute, but let's just do f64. That's of a data type float64, and that's also, I'm going to keep it as 10.6. You'll print that, do format.println. I'll say here float32, and that's equal to the f32, and exactly the same thing for the 64. Okay, right, so let's compile that again. And you can see here float32, that's 10.6, float64, that's 10.6 also, no problem. But let me show you, or let me demonstrate to you the difference in precision between the float32 and 64. So let me create a variable. I'm gonna call it, let's say HP, high precision, right? That's of data type float64, because we said that the float64 is used for higher precision. And that's going to be equal to 1.1 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, for example. Okay, and exactly the same thing for the 32, right? But instead of HP, we're going to say LP, low precision. Let's print both, right? So let's compile that again. Let's run. And it's clear to you now that the float 64 has higher precision than the float 32. So this was the float 32 and 64 in Go programming language. The next data type is the Boolean type. So I assume that you understand what Boolean data type is. Booleans are simple data types that can hold either true or false, nothing else. Okay, and typically is used for conditional testing. So we want to check out if certain condition is true or a certain condition is false. So simply you will try to do, if you want to check out if certain reactor or machine is active or not, and you're going to give it a data type of bool. So that's the data type B-O-O-L, bool, and you're going to give it a value of true. Again, you can put semicolon or you can ignore the semicolons. It's going to compile just fine. All right. Also, you can change that and we can say here that is on. Right. Let's actually print that. So we're going to format print ln. We're going to say here is active, and that's going to be concatenated with is active. Right, and the next one is on. Right, let's compile that again. Let's run our code, and you can see that it has displayed is active true, is on false. These are the Boolean types in Go language, true and false. And the data type itself is written B-O-O-L, bool. Now let's go ahead and check the next data type. That's going to be complex type here. So complex numbers have a real and imaginary part, which are both floating point numbers, by the way. And Go supports complex numbers with complex 64 and complex 128 types. So let me show you how we can do that. So again, I'm going to use the var keyword, and I'm going to, it's just saying complex number, CN, and the data type here can be complex 128. And also it could be 64, and that's equal to complex. And here we take two different arguments. The first one is real and the second one is imaginary. So you can pass 5 and 10, for example, right? The same thing here for the 64. You can do 2 and 7. So maybe I can change that, CN1 and CN2. Let me print both. So I can print the first one and the second one. Compile, run. And you can see here, first of all, that both are on one line because, again, this is an ugly function that just prints without, appending any spaces or anything. So I'm going to, do like that. And I'm going to use format.println. And let's say cn1 is equal to, and that's going to be cn1, and the second one for cn2, right? Compile, run. All right, awesome. So now you can see that this complex number has first part, which is the real part, which is number 5, and the imaginary part, which is number 10. The same thing for CN2, but this is complex 64. So 64 and 128 both are complex numbers, and in essence they are floating point numbers. Right, let's go to the last data type, which is the string. So section 5 is string data type. So again, I'm going to use the keyword var to declare my name variable, and that's going to be a string data type. And let's assign to it a value, let's say Kermit the frog, right? So the value of that name data type is Kermit the frog. And you can, of course, print that. So format println, and you will say here, my name is, and concatenate it with the name. Right, let's compile and let's run. And you have here, my name is Kermit the frog. Alright guys, so these were the primitive data types in Go language. Thank you so much for watching, and I will see you in the next lesson where we're going to study variables. Hello and welcome back. In this part, we're going to study variables in Go programming language. First of all, let me just import the main package, import the format package as well. Let's create our main function. And now we are ready to write our code inside our main function. So in the last lesson, we have been introduced to the var keyword, and that's a reserved keyword to declare a variable. And as you have seen the last time, variables can be declared first and then initialized later. Like you would do, for instance, var mango, and that's of data type string. Then you would assign here mango to be equal to this is a mango. Similarly, you can do the same thing with integers. So you can do var weight of data type integer, then you would assign weight equal to 34. So variables declared with the var are statically typed, which means their type cannot change, but their values can. So once you have created weight, you cannot create another variable with the same name weight. However, you can change the value of that weight. So let's say that we have a weight here that's equal to 34 and the mango is equal to, this is mango. Let me go ahead and compile that real quick. And of course, the format package, the mango variable and weight variable are declared but not used. So maybe we can print that. So we'll do here format print ln. And I'm going to print first the mango. And also I want to print the weight. Now let me just check if we have our main.go. Okay, so it actually hasn't compiled. I think now it has compiled. Yeah, okay. So we have, you just minimize a little bit. So now we have two files, the main.go and the executable. So let me run the executable. Okay, this is a mango and 34. Now take a look if I will change the 34 to 54, for instance, and here I will say this is a big mango. Now let's go ahead and compile again. All right. And you can see that the changes have been applied. This is a big mango and 54. So this is actually the first way to declare and assign. So declare and assign on two different lines. However, you can do this differently in Go. Actually, there are two different ways to do declaration and assignment. Way number one, way number two, and that's to declare and assign on the same line. So the way to do that simply is, again, you're going to use the var keyword. Let's do height this time. And the height is of data type integer, and I'm going to assign here 23. All right, so here we have declared and initialized or assigned in the same statement. All right, and let's run that. Let's see what we'll have. So we'll compile and we'll run, and no problems at all. The code has compiled perfectly and has printed all of the values assigned to those variables, the mango, the weight, and the height. However, I want to show you something very interesting. Let me first go to the Go extension because I haven't installed it, or I've installed it and uninstalled it because it kept forcing things that I wanted to avoid while recording this tutorial. I'm going to install that and I'm going to show you, if we're going to keep this way, what the linter is going to tell us. Take a look at that. You see those squiggly lines? If you will hover over, it tells you here, should merge variable declaration with assignment on next line. So you can do var mango string on one line and assign that value to the mango on a second line. However, the linter is suggesting that you can actually do like this. Now this line has disappeared, and exactly the same thing you would do with the weight. Again, this line has disappeared. All right, so this is the usefulness of the Go extension. Of course, it's very important to have it. If I'm coding in Go, of course, I will leave it. And by the way, it has 12,700,000 downloads, or 800,000 almost downloads, and it was created by the Google team. Right, now we have a third way to declare and assign to a certain variable. Now the shorthand is a very interesting one and unique to Go. So the shorthand notation is written this way: colon and equal sign. So this is the way to write your shorthand in Go. Let me show you. So let's say that I want to declare a variable called age, and the age here is going, that's going to be an integer, right? And I'm going to give the value 23. Now in Go, there is type inference. So by the way, if you will delete the data type, that's going to compile fine. To prove you, I'm going to do like this: print age. We should see 23. Okay, so you see here 23. So that means that we have in Go type inference. All right, but that's not the point that I wanted to show you. Of course, type inference is very important, but I wanted to show you the shorthand notation. So I'm going to, so maybe you can do like that. I'm going to comment this line out. Instead of writing this way, var age int equal to 23, simply you would do age with the colon equal to 54. All right, so take a look. It's beautiful, concise, minimalist, and simple. You're declaring the variable, which is age, and assigning to it a value of 54. Let's do my age is and concatenate it with the age. All right, let's compile again. Let's run. And you see here my age is 54. That's very odd. I've chosen the same number, 54 and 54, for the weight and the age. All right, guys, so these are the three ways that we have to declare and assign values to our variables. One, by declaring and assigning on two different lines. The second way is to declare and assign on the same line. And the third way, which is my favorite, is to use the shorthand notation by simply, omitting the keyword var, writing our variable's name, and assign to it the value that we want. And you can do the same thing for string. So you can say city is equal to, let's say, Washington, right? And that's going to, of course, print it, city and city. Right? I've used print again, dot println. Let's compile that again and let's run it. Now you can see that my age is 54, my city is Washington. You started to see how simple and concise the Go syntax is. So you can do multiple declaration and assignment on the same line. So let's say I want to create two different variables. The first one is apples, the second one is oranges, and both are of data type int. And I can assign to those two different values on the same line. So you can do here 23 and 54, 78, okay, whatever. Okay, so these are my two variables. Instead of doing things on separate lines, imagine you would do this using the first method. How many lines you're going to write, right? Here is simply on one line, and you can print them. So format.println, you can say here I have, and that's concatenated with apples. We say here apples, and concatenated with oranges, and printing oranges, right? So let's compile, run. So you see here I have 23 apples and 78 oranges. We can add things, by the way. So let me declare this fruits, and fruits here is going to be apples plus the oranges, and we can print that format.println, and simply we can print the fruits variable, right? So we can do like this, or maybe you can make it like that. Okay, let's compile again. Let's run again our code, and you can see here fruits is 101. All right, let me give you another example for strings. So I can say here var Windows, Mac, and Linux. That's of data type string. Okay, and that's going to be equal to different values. So we have more than two values, right? You can do any number of variables on the same line. So you can do here Windows is okay. Next I would do Mac is meh, no offense guys. And again /n, and the last one Linux is the goat, right? And again with a new line. Right, so this is another example of multiple string declarations. Right, now I can print those not using the format package with the println function, but using the simple print function, as we have used a new line after each sentence. So we'll say here Windows, Mac, and Linux. Okay, let's do like that. Let's compile and let's run. And we can see that we have appended a new line after each phrase. You will find this in almost all of the programming languages, so it's nothing new in Go. Now let me show you if I want to do static type declaration. So static type declaration. Again, I'm going to use the keyword var, and I'm going to give that variable x name, and that's going to be of data type float 64. I'm going to give that a value of 20.5. Now you might ask yourself, so what's new? We have seen this before. Yes, but you didn't know that this is called static type declaration. The static type declaration means that the type is explicitly stated in the variable declaration, and you will not leave it to Go to do type inference. And for you to understand, this is actually very helpful to the compiler. Why? Because the compiler understands exactly when you do that what type the variable is without needing to interpret the type from the assigned value. So you will not leave the burden to the compiler itself to figure out what data type your value is. And of course you can print that, right? So this we have seen a million times, but we can actually print the type of that variable. So for that I'm going to use a new function called printf. So printf is another function imported with the format package. So we're going to do, let me just do like that, x is of type, and I will use the %sign t /n for new line, and I'm going to pass that x. Now if we will compile, if you will run, you'll find here that x is of type float 64. That in contrast to the dynamic type declaration, where we can actually infer the type of the variable from the assigned value, making the type declaration optional. And that we have seen it when we did the shorthand notation using the colon and the equal sign. And that makes the compiler work more to interpret which data type is your value. So let's say that we have a variable y, and I'm going to use the shorthand notation with the colon equal sign equal to, let's say, 89. And now I can do exactly the same. So I'm going to just make like that. I'm going to move them down here below. And instead of x, we have y, y, and y. So let's compile again. Let's run. You'll find that y is of type int. Now, the last type of declaration, guys, in this lesson is the mixed variable declaration. So let's say that I want to declare multiple variables on the same line. So A, B, and C. Let's just add some spaces, and that's going to be equal to, you know, whatever, 5, 8, and foobar. Now, if I want to use the format.println, and I want to print A, and I will print B, and I will print C, and let me just change that for let's do 758.52, and let's print the type of that. So again, I'm going to use that here, and let's check out together the output. So I'm going to compile again, run our code, And we can see clearly here that the Go compiler has done the type inference for all of those variables. So A is of type float64, the Go compiler has figured this on its own. The same thing for B as an integer and C as a string. Alright guys, so this was simply how to declare variables and assign values to those variables in Go programming language. Thank you so much for watching, and I will see you in the next lesson where we're going to study the constants in Go. Hello guys and welcome back. In today's lesson we're going to study constants in Go. So constants in Go are immutable values known at compile time, and they cannot be changed during the program's execution. So they can be of any basic data type like integers, floats, characters, or strings. And let me give you some examples. So the first thing, of course, that I've done is that I've imported the main package, importing the format package, and we have our main entry of our program, the main function. So you can use the keyword const to declare a constant. Now, a good practice when you declare your constants is by using your caps lock. So I'm going to say here name like that. And that's going to be of data type string. And I can say here John Doe, for instance. If I want to declare a price constant, so I'm going to say here price like that. And that's going to be of data type integer. And that's 100, for example. You can do the same thing with floating points, and let's print all of that. And let me print all of that. So print ln, name, price, and pi, but maybe we can change this a little bit. And we can say here, for instance, name is, price is, and finally the pi is, pi value is, and concatenated with the pi. Now let's go ahead and compile our file. So this is cnst or const.go. I'm going to do go build as always. So go build an executable, which is an output file. Right now we have our main.exe, our executable. So let's run that, and we'll have here name is John Doe, price is 100, and pi value is 3.14. Also, we have integer literals. So the integer literals in Go can be decimal, octal, or hexadecimal. So the prefixes specify the base. So for example, you have 0x, that's for the hex, and also you have 0 for the octal. Just comment this line out and let me show you. You can actually declare different constants in one time. So you can write the keyword const, you open parentheses, and you type whatever you want to type. But again, I prefer to write the constants in caps lock, 255. You have also the octal, for example, and you have the hexadecimal. All right, so decimals with no prefix, the octal with the leading 0, so should always start with 0, and the hexadecimal with the not the 0 but the 0x. And if you will print that hexadecimal, all right, let's take a look. Let's try to recompile the file. Let's run the executable. You'll find here that you have the decimal equal to 255, which was really clear. For the octal, also the value for the 0377 is 255, and for the 0xff is also 255. The next constant category is the floating point literals. Now, a floating point literal, as you can see on the screen, can have an integer part. Also, it can have a decimal point, a fractional part, and an exponent part. So let me give you an example, and we have already this pi right here, so maybe I can take that, I can just put it here, and also the printing, right? Also I can define the Avogadro, and the Avogadro is 6.022E23, and also I can just make like that. Can do here Avogadro. Right, let's just try to recompile the file and run that one more time. And you can see here that it has compiled and printed with no problems. Also for the constants, you have the escape sequences. So this is a very important part of the Go programming language, the escape sequences in the string literals. Right, so these are special characters in strings that can be represented using escape sequences. So for example, and this is one very famous example that you have seen it already, when you want to add a new line, you actually type \n to add a new line. So we can say here greeting, and we can say here hello Earth. Right? And at the end of the word Earth, we can add this \n to add a new line. Also, there is an escape for the quoting. So you can say here quote. And what I want to say is Go is simple as a quote, and the one who is quoting this is a programmer. And the way to do that is by having just / wrapped in double quotes. And we can say here Go is simple. And don't forget another / and you can say here a programmer, and also shut it with double quotes. All right, so let's try to print that out for the greeting and also for the quote. Let's go ahead and recompile that. Let's run the file, and you can see here that we have hello Earth. Appended to that a new line, then we have our quote. Go is simple. This is wrapped in double quotes, a programmer. Also, there was the alert or the bell. So the alert or bell, that's by doing this escape sequence with the / a. Let me give you one more. You can do line breaks. So line breaks, let me just declare this constant LB is equal to, let's say for instance, I with the /n am /n Batman with the /n again. All right, and let's just print that. So these are some of the escape sequences that are available in Go. Certainly you can browse the Go website and you can check out some of the escape sequences that are available. All right, so let's go ahead and recompile our file. All right, awesome. So I see that it hasn't printed the bell. That's something in my terminal, but it might work in your case. And for the line breaks, you can see that it has printed actually each word on a separate line. We also have multi-line and concatenated string literals. So strings can be extended over multiple lines and concatenated using the plus operator, or just simply by placing them next to each other. So let me give you an example. Let's use again the const keyword, and I'm going to call this constant multi-line, and I would say here, and I will concatenate that, multiple clouds. So I'm going to declare another constant. Now we can print the multi-line and we can print the concatenated. Let's recompile the file, and you can see that it has actually concatenated using the plus operator. And you can do like that, by the way. Just add a space. Right, so that looks better. So constants can also be Boolean, indicating a binary state. So if you would do const active, for example, equal to true, and we can say the same thing for, let's say, ready. And if we will print that, so we have the active and also we have the ready. So you can actually declare Boolean constants in Go, not only variables. So let's go ahead and recompile. Let's run the executable, and you can see here that active is true, ready is false. So let's say that I want to declare a constant called length, and that length is equal to 50. Also, I need to have a width, and that width is equal to 5. And also I want to have the area, and the area is the multiplication of the length by the width. And let's just print that. So let's take a look. And you see here that the area is 250. So the calculations were successful, which means that you can indeed declare constants used for simple calculations or even complex calculations for that matter. And with this comes the end of the 5th lesson in Go constants. In the next lesson, we're going to study operators. Thank you so much for watching, and I will see you shortly. Hello guys, and welcome back. In this lesson, we're going to study operators in Go language. First of all, what is an operator? Not only in Go, but in any other programming language. An operator is a symbol that tells the compiler to perform specific mathematical, not only mathematical, but also logical manipulations. And it provides a lot of types of operators. Those types are arithmetic operators, relational, logical, bitwise, assignment, and miscellaneous operators. So we're going to check out some of those operators in today's lesson. So I have here my main function. Let me just delete that line. I don't need that. And we're going to assume that we have two different variables, a and b. So a, for instance, is going to hold number 10 and b is going to hold number 20. All right, two different variables. Now, if we want to add a plus b, that's going to be format.println a plus b in double quotes, and we're going to pass the a plus b, the actual a plus b that we have hard-coded them. So that's as far as addition. Also, we have subtraction. So we can do the same thing, but instead of a plus b, it's going to be a minus b. So the result of the addition should be 30, and the result of the subtraction should be minus 10. Also, we can have the multiplication. So we can multiply a multiplied by b, or a by b. That's going to be 200. And finally, we can have division. So a divided by b, and that's going to be 5. We have also what we call the modulus. So the modulus simply is the remaining of the division. So let's say, for instance, that a modulus b, that's going to result in 10. And I might give you a better example than that. So let's have, for instance, C and D. And let me just define them up. So C here is going to hold, let's say, for instance, 11. And let's do like that. Let's do 3, for instance, right? So the remainder here is going to be what? What do you think? With a remainder of 2, since 11 minus 9 is equal to 2. Also, we can increment or decrement a certain variable by adding plus plus or minus minus. So in this case, we have a plus plus. So if you will do format println a plus plus and you will print the incremented variable, that's going to give you 11. And exactly the same thing will apply for the decrementing value. So we have incremented 10 by 1, so the result is 11, and then we have decremented that result by 1, it returned back to 10. So the original value of the a variable is 10, we have incremented it by 1 to have 11, and again we have decremented it by 1 to get again 10. All right, so these are the basic operators that we have in the arithmetic operators: the addition, the subtraction, multiplication, division, modulus, increment, and decrement. So before we move on to the relational operators, let me go ahead and check that file out with you guys. So you can see here that we have a plus b equal 30, a minus b minus 10, the multiplication 200, the division is 0, the modulus is 2, and we have here the incrementing 11 and the decrementing 10. Relational operators, what are they? Well, they compare the values of two different operands. So we're going to assume the same example, a and b. A is holding 10, b is holding 20. The first one is equal to. So we're comparing two different operands, a and b. We're going to check out if a is equal to b. Format.println, and we're going to check out if a is equal to b. Of course, the output is going to be false, right? Because a is not equal to b. A is equal to 10 and B is equal to 20. The second one is not equal to. So let me just copy that and put it here, and we're going to check out if A is not equal to B. A is equal to 10 and B is equal to 20. That means that A is not equal to B, and the result is going to be false. A is not equal to B. That in fact is true because A is not equal to B. The next one is greater than. So in greater than, you would check out, if A is greater than B. And in this case, that's going to return false because B is greater than A. Also, we have less than. That's going to be exactly the same thing. So you can just do like this. That's exactly the same thing, but the reverse. So that's equal to true. And of course, we have greater than or equal to. So here we are saying if A is greater than or equal to B. If that's the case, that's going to return false as a result, right? Because A is not equal to B, nor it's greater than B. And similarly, less than or equal to. This case is going to be true, right? So equals, that's equal to true here. There you go, guys. These are the relational operators in Go. And let's move on to the next type of operators, which is the logical operators. Actually, they perform Boolean logic operations. So again, we're going to assume our two variables here, A and B, but instead of 10 and 20, I'm going to just copy that, and instead of 10, I'm going to say true, I'm going to say false. And the first logical operator is AND. So let's do format.println, and I'm going to say here A and B. It's going to be falsy. The next one is OR. So in this case, you're going to choose either A or B. A very simple example is the weather condition. So let's say, for instance, that if the weather condition is rainy and muddy. So if it is rainy and muddy, that's going to be false. Rainy or muddy, that's going to be true. And that depends on what you want actually to do. If it's rainy and muddy, don't go to work. If it is rainy or muddy, you can go to work. For example, I'm just trying to simplify it for you guys. This logical operator OR, its sign is double pipes. And the sign for AND is double ampersand. Right? I'm quite sure you have seen this in JavaScript or in Python. So the next one is the logical operator NOT. So if the weather condition is not rainy, let's say that A is true or rainy, you're saying here that not true, which means false. And that's basically it. Let's also do it on B, by the way, just to show you that if not B, which means not false, that means it's true. A and B, that's false. A or B, that's true. If not A, that means not true, means false. If not false, which means true. Also, another kind of operators in Go is the assignment operators. And the assignment operators in Go, they are used to assign values to variables. That's all what it is. So again, we have A and B equal to 10 and 20. Then here you want to assign B to A. That simply means A is equal to A plus B. So you're actually creating a new value for A, which is going to be equal to 30. So you're overriding A by assigning it the value of B. And exactly the same thing for the subtraction. So A now is 30, right? Because initially it was 10, then after we have assigned it to B, it became 30. Now you can do 30 is equal to 30 minus 20. So 30 minus 20 is equal to 10. Let's take a look, and there we go. A plus equal to B is equal to 30. A minus equal to B is equal to 10. Next type of operators in Go we have is bitwise. So bitwise operators simply, they operate on the binary representation of integers. Let's take the first one, bitwise and assignment. So let's say that C holds the value of 30, and by the way, the 30 is 11110 in binary, all right? So to perform the 30 and 2, we're going to do the bitwise and assignment. So we want to perform that 30 and 2. The 2 is 00010 in binary. That's going to result in 00010. And that's going to result again in 00010, which is 2 in decimal. So the 30 here is going to become 2. So if we have 30 in decimal is 11110 in binary, we have also 2, which is equal to 000, there we go, 00010 in binary. If we're going to do the bitwise AND, you'll have the C as 2, not 30. And let's take a look to the first result, and there we go. The second one here is the OR, C OR 2. The output here is going to be 30. That's going to set the bits which are set in either C, which is 30, or 2. So the output is going to be 30. The bitwise XOR with this caret, so C caret 2 is equal to 28. Not, that's going to be minus 31. And that's a very interesting one because when you will do this, the bitwise not, you're actually flipping all of the zeros to ones and all of the ones to zeros. And for the bitwise left shift, this one is very, very interesting. That's basically shifting the bits of C one position to the left. So you're multiplying actually the 30 by 2, which will result 60. And the opposite, that's going to be one position to the right, which is going to be 15. And that means 30 here is divided by 2 and not multiplied by 2. Right? So again, that's not very important now, but it's good at least to know what's possible, that you can manipulate the number of bits. So this is as far as the bitwise operators. The last type of operators in Go is the miscellaneous operators. Those are other important operators in Go that include the address of operator and the pointer dereference operator asterisk. Let's take a look to the address of operator first. Let's have PTR, which stands for pointer. Pointer is a reference to the A variable. And let's check out if we'll print that. We'll have here address of A is that address. This is the memory address location of the A on your computer. Also, you have a pointer dereference operator. So you're referencing and dereferencing for memory optimization. So what you're going to do here is to have the asterisk in front of the PTR to dereference the operator. And once you will do that, you will get the result of 10. So that's it for this lesson, guys. Thank you so much for watching, and I will see you in the next 2 lessons where we're going to study the control flow in Go, which is the if-else statement and the loops. Thank you, and I will see you shortly. Hello guys, and welcome back. In this lesson, we're going to study the control flow in Go language. Now, control flow is not only about conditionals or if-else statement, but also loops. Control flow, in its broader term, of course, is a way of deciding which blocks of code to execute based on logical conditions or user input. And this is crucial for building dynamic programs that can adapt to varying scenarios. So the most common control flow tools in Go and in any other programming language really are conditionals. So we have if and if-else and loops, and also switch statements which behave exactly the same as conditionals. So first of all, in chapter 7, we will have the if-else statement or the conditionals. So the if statement executes a block of code if the condition is true. For example, if it's raining today, don't go to work. So that's a condition, and based on that condition, the consequence or the result. So let me show you how to do that in code. Let's have a variable, age. Age is equal to 18. Now we can check out if the age is equal to or more than 18, you can vote. You're eligible to vote. We'll use if age is more than or equal to 18, we will print out you are eligible to vote. So if that condition is true, we will print you're eligible to vote. So let's run that program. And we have here the printing statement, you are eligible to vote. So let's change that to 19, for example. We have the condition if age is equal to or more than 18. So that's going to run the same thing because that condition is true. Age is more than 18. Now, if we'll do 17, for example, we will have absolutely nothing. And here comes the usefulness of else. So we'll have if else. The else basically provides an alternative block of code if that condition is false. So in that case, I want to add else here, and I want to print something that you're not eligible to vote. Now we have you are not eligible to vote printed. Again, let's do 18, and that's going to change based on the input. You are eligible to vote. Right, now let's check out the nested if statement. So you can have nested if statement. What does mean nested if statement? You will have different if else statement in one code block. So let me just comment those lines out. Now let's say that we have a score. That score is equal to 82, for example. Right. I want to check out if the score is greater than or equal to 90. In this case, I want to print out grade A, for instance. So if the score is greater than or equal to 90, I will print grade A. Now I will have different condition in the same code block. I want to say if, but that's not quite right. It should be preceded by else. So else if, it's exactly the same in Python elif, and else if in any other programming language, you'll find else if. Else if the score is greater than or equal to 80, I want to put another condition. I want to check out in that code block if score is greater than or equal to 85. Let's make 85, right? In that case, I want to print out grade B+. And for any other conditions, so the else here is only for that code block, not for that code block if score is greater than or equal to 80, but rather for if score is greater than or equal to 85. In that case, I want to print out grade B in case that the score is greater than or equal to 85. And for any other case, I want to print grade C, right? So we have here greater than or equal to 90, that's grade A. Then we're checking out else if score is greater than or equal to 80, but that's not all because we need to differentiate between what's greater than or equal to 85 and any other case. So if it's greater than 85 or equal to 85, that's grade B+. And if it's less, so it's between 80 and 85, or 84 rather, that's going to be grade B. And for any other cases, that's going to be grade C. Right? So this is what I meant by nested statements. And let's actually run that file. So here is grade B because we have a score of 82. And we said that between 80 and 84, that's going to be grade B. If we will change that to 86, that's going to be B+. If we will change that to 50, that's going to be C. And if we will change that to 95, that's going to be grade A. That's it. Thank you so much for watching, and I will see you in the next lesson. Hey, what's going on everyone? Welcome back to Control Flow Loops. So we're going to dive in a little bit into how loops function in Go programming language. We're going to use some practical examples to illustrate different types of loops and loop control statements. This is going to include the for loop. So let me just write that. We'll have the for loop. We will have nested loops as well. So nested loops, nested loop control. Also, we'll have loop control statements like break, continue, and go-to. And if you're a retro programmer like me, you might have encountered the go-to statement in BASIC or VBA, Visual Basic for Applications. So we'll have here loop control statements like we have break, right? We have continue, and we have go-to. Right, so those are the loop control statements that we have. All right, first of all, let's start by the for loop. The for loop in Go is very versatile. It allows you to execute a sequence of statements multiple times. Let me show you. Let's try to count to 10, for example. That's a very basic example, but it's going to show you at least the syntax, even if you know that in JavaScript or Python or Rust. We're going to see that in Go. All right, so let's first have the main package and let's import the format, and let's have the func or the func main. Forgot actually to write that. Right, so to use the for loop here, you would say for I is equal to 10. If I is less than 10, we're going to increment I by 1. So again, for I is equal to 10, so you are actually defining a variable called I and assigning it a value of 0. So that's the initial point. For I is equal to 10, unless I is less than 10, I want to increment I by 1. So I++ means I equal to I plus 1. You're incrementing I by 1. And in each iteration, this is called an iteration. So for each iteration, I want to print the iterator. The iterator here is I. And in that case, you're going to print the numbers from 0 to 9 because you start by 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 times the I has iterated from 0 to 9. Not from 0 to 10, right? From 0 to 9. Let's check out if we will run our program. There you go. 0, 1, 2, 3, 4, 5, 6, all the way to 9. Right? If you want from 0 to 10, you're going to have here 11. Right? Because in programming, that's zero-based concept. You start by 0. The second form of a loop that I want to show you is the nested loops. So the nested loops involve a loop inside another loop. That's often used for multidimensional data structures. So it might look complicated at first, but believe me, it's not. If you will destructure each loop and you will understand its logic, that's going to be very easy to put back the picture together. So let's take, as I told you, the multiplication table here. So again, you're going to start with a condition. For I is equal to 1, while I is less than or equal to 10, I want to increment I by 1. But that's not all. We'll have a second for loop. For j is equal to 1, while j is less than or equal to 10, I want to increment j by 1. In that case, I want to have the I, the first iterator, the j, which is the second iterator, and then the I multiplied by j just to display the result. So the result here would be you're going to multiply each number by itself 10 times. So 1 by 1, 1 by 2, 1 by 3, and so on. 2 by 1, 2 by 2, 2 by 3, and so on. From 1 to 10. That's why we have started by 1. Let's take a look. And there we go. It looks insane. Just make like that and just minimize a little bit. So you will have here the multiplication table of 1, 2, 3, 4, 6. That has shifted here because of the zeros. So yeah, we have actually printed the multiplication tables of 1 till 10, which is awesome. And you did that actually by 3 code lines. You can actually change that. You can make it 5. And here also we're going to make it 5. So let's try that out. And you have here, indeed, that's more viewable, the multiplication tables from 1 to 5, which is awesome. Next, let's check out the loop control statements. So let me just make like that. And oops, just make like this. All right, so we have here the loop control statements. So these statements here modify the execution flow of loops in Go. First of all, we have the break statement. The break statement has one purpose only, to stop the loop after a certain condition. We have a for loop for I equal to 0. While I is less than 10, I want to increment the I by 1. And if I is equal to 5, break outside of the loop. So for each iteration, you're going to print out that iterator, that number. And it's going to exit the loop after reaching more than 5 iterations. So let's check that out. It has iterated over numbers 0, 1, 2, 3, 4. They are 5 iterations. Now, the opposite of the break statement is the continue statement. So if the break statement just stops whenever a condition is met, the continue statement is going to, skip a certain condition. So if a certain condition is met, we're not going to exit the loop, but continue. So let's say, for instance, that for I is equal to 0, while I is less than 10, I want to increment the I by 1. Now, I'm going to check out for a certain condition. If I modulus 2 is equal to 0, which means that's an even number. In case of an even number, I want to continue. I will not print that number. So I will end up by printing only odd numbers. And that's the usefulness of the continue control statement. The continue control statement actually is going to continue whenever a certain condition is met. And that's what I meant when I told you that's exactly the opposite of the break statement. So let's check out together how this code is going to behave. Let's run our main program. So you can see clearly that the program has totally ignored any number divisible by 2. It's just printed 1, 3, 5, 7, and 9. And finally, we have the go-to. So again, we're going to start by the initialization for I is equal to 0, the condition while I is less than 10, and the increment, I incremented by 1. And after each iteration, the program is going to run this condition. If I is equal to 5, go to end. And the end here is printing statement loop ended, right? So it has printed 0, 1, 2, 3, 4, 5, and loop ended because the condition here was met. The condition is if I is equal to 5, go to end. What's the end? The end is to print loop ended. I is equal to 0. Next, I want to say that if I is less than 10, I want to print ln that iterator. Then I want to increment the iterator. Now I want to have a label. The label here, I'm going to say loop like that. So that's going to be a label. And I will say just go to loop. So let's check that out. And effectively, we have printed numbers from 0 to 9 because after each iteration, we went to loop. Just to be clear, let's call it start, right? We're going to jump to the start. So after each iteration, go to start, right? That's going to do exactly the same thing. The last thing that I want to show you is the infinite loop. That's nothing impressive, really. Infinite loop. So simply the infinite loop in Go is that simple. For, and that's it. And that's going to print infinite loop forever. What you would do actually in something like basic language, something like this. Print this is an infinite loop, then 20, go to 10. So after each iteration, we didn't have the for. That's going actually to do the same. And I'm not really sure if I'm tried this now, that's going to do the same thing or not, but yeah, let's try that out. Let's try the simple infinite loop, and then we'll try the old basic way. Maybe it will work, who knows, right? So of course, that's going to block everything. interrupt that loop by hitting Control C. So that's the infinite loop. You know how to do it. Basic way. We're going to do format.println, and maybe that's the start. Maybe you can do here the label start, right? Go to start. Let's try that out. Maybe it will work. Who knows? Yeah, it works just fine. It works exactly like in basic language. So that's everything that I have for you guys. These examples should give you a clear picture of how loop works in Go. Thank you so much guys for watching, and I will see you in the next lesson. Hello and welcome back. In this lesson, we're going to study functions in Go. In Go, as in any other programming language, a function is a reusable block of code that performs a specific task. Functions help organize code, make it more modular, and also allow for code reuse across a program, which means that you can write a function once and call it many times across your program. Also, functions can accept parameters and return values. So far, what you have seen is the main function, which is your entry point to your application. And it's no different from any other function. So it starts by the keyword func, followed by the name of the function that you want to choose for the specific task for which you have designed your function in the first place. Then this function is going to take parameters. So parameters can be anything. Can be a string, can be integer, can be a boolean, whatever. Following that, the return type, which means that which kind of data type you want that function to return. A string, a boolean, an integer, it's you who decide. And finally, here inside those curly brackets, you will have the body of your function. This is the syntax of a function in Go. So let me comment those lines out. And let me show you now if I want to create a function that will display the name of the capital of a country, for example. So to do that, let me just maximize a little bit. You'll type the keyword func, followed by the name of the function, right? So we can say capital. The sayCapital function is going to accept a parameter. Let's say that's going to be s, and s is a string. Then in the body of the function, I've used the format package .printf, which is in itself a function or a method. So printf stands for print format because we want to return a string. So inside the parentheses and double quotes, you will have the %s, and that's the s, that's the parameter that you're going to pass to the sayCapital function. So as a parameter, you can pass, let's say, Washington or Paris or Cairo, whatever. So in the sayCapital, you have set your parameter, and also that parameter or that argument is going to be passed in the format.printf function. So printf, we're going to pass the s with the %. That's going to be substituted by whatever the argument or the parameter that you're going to pass in the sayCapital function. We can also create another one, and we can call it, let's say country. And we're going to say also the text here, say country. So that's what I said when you can write the function once and evoke it or call it many times. So I'm going to call the sayCountry function, and I'm going to pass here USA and sayCapital Washington. By the way, the order here is not correct, so I can say here is the capital. That's step 9, guys. Not my fault. Don't trust AI too much. And here we can say is the country, right? Because that's going to be substituted by the parameter that you're going to pass through your function. So the country here is going to be USA, and the capital here is going to be Washington. All right, let's go ahead and run our application and see what we will get. And we got no errors. USA is the country, Washington is the capital. So let's say that I want to create a function that calculates the maximum value. So that's going to be a function to find the maximum between two numbers, let's say. So I'm going to start by the func keyword, followed by the name of the function, and that's going to take the parameters. So I can pass multiple parameters, not only one. So the first one is n1 and the second one is n2, and that's going to be of data type int, and also it's going to return a data type int. Now I want to check if the first number is greater than the second number. I will return that first number, else I will return the second number. So for the first number and the second number, oops, I don't want that from tab 9, I will create a and b, and that's going to be equal to 100 and 200. And I want the result, which is going to be equal to the maximum function, right? I've invoked that maximum function here, and I will get the result of that function stored in a variable called result. So max a and b, and then I'm going to print it. So we can do format.printf. I'm going to pass here, a string. We can say max value is, and that's going to be $d with escape sequence for a new line, and the result is going to be passed here, which is essentially going to hold the result of the maximum of both numbers a and b. So you can see that we have written the max function here and invoked it in the main function exactly the same way like we have done with the say capital function and the say country function. Awesome. Now let's go ahead and run our main program, and you can see that the maximum value here is 200 because it has done the comparison successfully between the first number and the second number. Also, you can return multiple values from a function if you want. So actually Go supports that. It supports returning multiple values from a function. And also I want to create another function which is going to swap two strings. So function to swap two strings. And to do that, again, I'm going to use the keyword func, and I'm going to call that function swap naturally. That's going to take two different parameters, x and y. Both of them are going to be string. Now I want to return two results or two values. Both of them are going to be string. So that's going to be string. The first one is string and the second one is string, right? We're going to do that. Oops. And simply we're going to return y and x. All right. So let's say that we have first name and last name. That's going to be x and y. And we have, let's say, John Doe, and we want to swap both of them. So let's go ahead and do that in the main function. So let's say, for instance, that I have first name and second, or last name rather, last name, and we can do swap, and in the swap function I'm going to pass the two strings, John Doe, and again we're going to use the print format function from the format package, and we're going to swap the names, the first name and last name passed inside our function. Let's go ahead and run our main program. So you see what the function has actually done. It has swapped both names. It has put the last name first and the first name last, right? Instead of John Doe, we have Doe John. Awesome. Now let's talk a little bit about the function arguments, right? Some of you guys confuse the arguments with the parameters. Actually, nothing to be confused about. So the arguments are used when you use the function, and parameters are used when you design your function. All right. Now I'm going to talk a little bit about the function arguments. So we can call the function by many things. You can call by value, for example. What do I mean by calling by value? So the default way to pass arguments, as you saw, is by value, meaning that any changes to the arguments within the function will not affect the original arguments, right? So let's say, for instance, that I want to create a function to try to modify the argument. So let's say that I want to create a function to modify its argument. I'm going to call that one increment, and that's going to take only a number, and that's going to be of data type integer. And we can take that number and incremented by 1. And let's actually do format println. And here I will say inside increment, and we'll pass the number. Now let's get back to our main function down here below, and here calling the increment function by value. And let's say that I want to have x to be equal to 10. Then I'm going to invoke that increment function and pass the x. And finally, I'm going to print that. So format println in main after increment, and I'm going to pass the x, right? And here, by the way, the result is going to be always 10. Let's take a look. In main after increment equal to 10, but inside increment equal to 11. You can also call your function by reference. So you can pass the reference of a variable, let's say the memory address of that variable, to the function that you're designing, so that the function can modify the original variable. Let me show you an example. Let's say that I want to create a function to modify a slice. A slice, by the way, is the same as a list in Python or array in JavaScript. Let's do func, let's do like that. Let's do func and call that modify. And that's going to take a slice, integer. And here the slice sub 0 is equal to 999. And let's do format dot println, and here we can say inside modify, inside modify and the slice, calling modify function by reference. And here I can create my list or my slice, and that's going that's going to be integer 1, 2, and 3. Invoke the modify function and pass inside the my slice, those the array basically. So what do you think the my slice is going to be? Is it going to be updated? Well, let's take a look. Indeed, it was updated. So inside modify, you have 999, 2, and 3. And in the main after modify, when we called it in the main function, we have also 999, 2, and 3. We have actually substituted 1 by 999. When we have created our modify function, we have changed the first reference in the slice to be 999 instead of whatever is here. So that's it for this lesson, guys. As you saw, functions in Go are fairly easy to grasp. Thank you so much for watching, and I will see you in the next lesson where we're going to study scope in Go. Hello guys, and welcome back. In this lesson, we are going to study scopes in Go language. In Go, scope refers to the region of the code where a variable is accessible. Understanding scopes, in my opinion, is very important because it's going to help you to manage variable visibility and lifetime. It's going also to ensure that your programs run efficiently and without any conflicts. Now, we cannot talk about scopes without mentioning the variables. So, variables in Go can be defined in different scopes, such as local, global, and function parameter scopes. We're going to discover in this lesson these different scopes to understand how they work. First of all, we're going to check out the local variables. Local variables are declared within a function or block and are only accessible there. So let's say that we are inside our main function and we want to get our variable declaration. So first we have declared our variables, then we have initialized our variables. We have A, B, and C. A has a value of 10, B has a value of 20, and of course they're both integers. And also C is an integer, which is the result of the addition of both A and B variables. And finally, you can display the values of those variables, A, B, and C. So we should see 10, 20, and 30. And let's run our program. Indeed, we have A10, B20, and C30. So in this specific example, A, B, and C are local variables, which means that they can only be accessed within the main function. Now you understand local variables, let's talk a little bit about global variables. So global variables are declared outside any function and are accessible from any function within the same package. Let me give you an example. let's do a variable declaration using, of course, the keyword var, and the name of that variable is g, and that's of data type int. Now, inside the main function, you can actually do the variable initialization. So what I'm going to do is I'm going to delete the c, and I'm going to substitute the c with the g. Now, this variable g is accessible from outside of the main function. So you can expect that g is going to do the addition of 10 and 20. Let's also change the c here for g, and also don't forget to change it here. We can say that global variable g. Awesome. Now let's go ahead and run our program, and indeed global variable g equal to 30. So we didn't get any errors. You can change those for 20. It's going to do the addition is going to be 40. But also we have variable shadowing. And shadowing, we have studied it in Rust. Now we're going to check it out in Go. So local variables like we have here a and b, they can have the same name as global ones. So you can have a and b as local, and you can also have here var a and b, and they're going to hide the global variable within their scope. Let me show you a practical example. So I'm going to have different ones. So let's say, for instance, let's have x, right? Let's have an x variable. This is a global variable. Also, I'm going to initialize x to be equal 100. Also, I'm going to declare and initialize x. So x is also an integer, right? And I'm going to initialize that and give the value of 100, for example. That's fine. And don't worry if that squiggly red line bothers you. That's simply because this variable is declared but not used. And of course, you know now that you can do it this way, or you can simply do like this. You can say here var x, and that's of data type integer, and that's 100. Or simply you can do like this, x equal to 100, right? That's going to be the same thing. Remember that we have a global variable with the same name, right? var x int, and we have also var x int here. Okay. The only difference is that x here is not initialized, it's only declared. Now we can display that by using the format package printf x equal to, and whatever the value of the x in our case is 100. So you have var x int equal to 25, which is a global variable, and you have var x int equal to 100, which is a local variable. So that's not going to conflict or anything. We can actually display that. So if you're going to print that, that shouldn't be conflict. And there we go. The compiler actually has printed x equal to 100. It has printed the local variable and not the global one. So in our case, this local g in the main function shadows the global g, which means that the global variable is not accessible within the main function. So that's everything that I have for you guys for scopes in Go. Thank you so much for watching, and I will see you in the next lesson where we're going to study strings. Hello guys, and welcome back. In this lesson, we're going to study strings in Go. Strings in Go are a fundamental data type that represents a sequence of bytes. It's in Go as in any other language. They are inherently UTF-8 encoded, which means they can handle a wide variety of text, including non-ASCII characters, without any additional encoding efforts. And this makes working with different languages and symbols straightforward in Go. Now let's go ahead and explore how to create, manipulate, and perform common operations in strings. First of all, how to create a string. So maybe I want to delete this line. And I can add a comment here, and I will say creating strings. So they should be inside double quotes like so. You can say here hello world, for instance, right? And let's assign this value to a variable called greetings. Now you can display the string using &s format specifier. So what you can do is you can type format dot print printf for print format, and you can say here normal string. And also we can do the same thing, but we can precede that by the %s. So you have the first argument, the format string, which is the %s. Then you will have your variable. In our case, it's greeting. And let me just add a new line here. Just do like that. /n. Now let's try to run this program, and we'll get normal string hello world. Awesome. It has compiled with no errors. We can also display the hexadecimal byte values of the string. So how we can do that? Let me just add a comment quickly. Display the hexadecimal byte values of the string. So how we can do that? First of all, I want to just print to the console a message. We can say hex bytes, for instance. Then I will use the for loop. I will say for I equal to 0, unless the I is less than the length of the greeting of the hello world string, I want to increment the I by 1, and then I will print the greeting sub iterator, sub I. So to do that, we'll simply say for I equal to 0, initial point, unless the I is less than the length of greeting, I want to increment the I by 1. Then what I will do here is that I will print to the console, print with capital P, print F. Now the X stands for the hexadecimal. So what you want to do is you want to print the greeting sub that iterator. And as always, I do this mistake. I type print with a small p, it should be with capital P. And then finally here, I want to do format.printf and a new line. Let's run that program. So we have actually displayed the hexadecimal byte or the hexadecimal bytes of the hello world with exclamation mark. So it took everything. It even took the space between the comma and the next word. Also, we can do measuring string length. As we have done here, the len function, we have applied it on that greeting variable. So you can pass whatever the variable of the string stored in it inside the len function to return the length of that string in bytes. So let's try to do that. Format.printf, and I will say the length of this string is whatever, and following that we can do instead of format we do print line, and we're going to take the length function and we're going to pass inside the greeting variable, right? Let's run that, and indeed we have 13 characters, right? The length of the string, which is hello world, 13 characters. And if you will count them, you will find here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We can also do concatenating for the strings, so we can concatenate strings using the plus operator. We can do that, or we can use a join function from the strings package. So we'll need to import the strings package here. So we have only the format. I will need to add the strings as well. And yeah, let's try to do that. First, I will create a slice of strings to concatenate, right? Because we need two different words in a slice, in a list. Let's do fruits, and that's going to be equal to an array, a list, a slice, string here, and we're going to pass those words. So apples, oranges, and bananas. Concatenating using strings.join that we have just imported from the strings package. So we will do format.println, and here I'm going to say strings.join, and I'm going to pass fruits, add a separator, and there you go, apples, oranges, and bananas. Even I've added an extra space here so I can omit that and get back here, clear the terminal, run that again. And there you go, apples, oranges, and bananas. So we have concatenated actually different strings with the join method. Right, so I think that's everything that I have for you guys today for strings in Go. Thank you so much for watching, and I will see you in the next lesson. Hey guys, and welcome back. In this lesson, we're going to study arrays in Go. In Go, any array is a fixed size. In Go, any array is fixed size. So if you have decided to put here integers, you need to keep them always integers. If you decided to put here strings, that should be always strings. You cannot put integer and strings in the same array. And this is the standard array mechanism that works in any other programming language, whether it's Rust, Java, JavaScript, Lisp in Python, and so on. So let me just write a comment here declaring arrays. And by the way, you will find the link to the GitHub repo in the description below. So I'm going to declare an array with the keyword var, and let's have this array called balance. This balance array is going to hold 10 elements. Those 10 elements will have data type of float32. As far as initializing the arrays, you can do it at declaration. So how we can do that? You can say var balance equal to 5 elements, and those 5 elements of data type float32, and you can define them directly, or you can initialize them directly. So 12.2, you can even omit the size of the elements to let Go itself infer it. So we can add here initialize while omitting the size of the array elements. So basically I'm going to copy that, and I'm going to take this and put it here, and I'm going to delete number 5. This is going to let Go infer the size, right? It's going to, let Go think about it and do it automatically. Now, the way to access array elements is by using the index. We start, of course, at index 0. So we can, this is the main function, of course, and we can have here our array. That's array called n that will hold 10 elements of data type integer. Next, we're going to initialize the array elements. We're going to say for I equal to 0, unless I is less than 10, I want to increment I by 1. And then I will take the n with the sub array, or the sub element, sub iterator, and I'm going to add to it 100. Then we're going to display that by printing it to the console. So let's go ahead and run that program. And what we have is indeed iterating through the elements inside the n array. So from 1 to 10, or from 0 index to the 9th index, which is number 10. And that's actually took number 100 and iterated by 1. So 101, so 100 till 109. All right, guys, so the most important thing to note here is that you have basically accessed your array using the index. And the index, of course, as we said, are or start with 0. This is a 0-based index system in programming in general. So you start the iteration from 0 and you end up by number 9, as we're going to 10 numbers. So the 0 index goes with number 1, right? The first iteration. The second iteration has a 0 index, goes with number 2. The second index has number 3, and so on. So the key points to remember here in this arrays lesson is, first of all, we have a fixed size. So the size of the array is fixed at declaration. Also type specific. So if you have an array of integers, always should be integers. If you have an array of strings, it should always be strings. And finally, 0 indexing, and we have explained that now in details, and the first element is accessed with index 0. And that's basically everything that I have in arrays for you. Thank you so much for watching, and I will see you in the next lesson. Hey guys, and welcome back. In this lesson, we're going to study pointers in Go. A little bit of introduction to pointers though. Pointers are very useful for working with complex data structures and optimizing performance. So we can say simply that a pointer stores the memory address of another variable, unlike regular variables that hold data directly. So to summarize, what is the difference between a pointer and a variable? Because a variable also stores data. Well, a pointer stores the memory address, as we said, of another variable. However, the regular variables hold data directly. So that's the critical difference between a pointer and a variable. To declare a pointer, we use the asterisk sign before the type. So let's say, for instance, that I want to create a pointer. I'm going to call it IP, for instance. And I'm going to use the asterisk in front of the data type. That's going to be of integer data type. You can use the same logic for any other pointer. So let's say that we want to declare a pointer that holds F32, for example. So this is going to be asterisk float 32. Now, the basic pointer operations are fairly simple. So these are the basic pointer operations. And the first one is storing the address. And that's very simple. You only use the ampersand sign to get the address of a variable. The second operation is called dereferencing. And don't be overwhelmed. Dereferencing simply means the process of accessing the value that is stored at a particular memory address which a pointer refers to. To understand this point better, we need to go beyond Go. So in programming in general, right? So pointers is a concept in programming and not in Go only. Pointers are variables that store memory address of other variables rather than holding actual data values. So when you want to access the actual data at the address pointed to by the pointer, you dereference the pointer. That's all what it is. So you use the asterisk sign or operator before the pointer variable, okay, in order to access the actual data at that address pointed to by your pointer. So that's all what it is. You use that asterisk symbol to access the value at the pointer's address, the actual data at the pointer's address, actually. So let me give you an example to put things in perspective. First, let me get the main package. Let's also import format. Let's have the main function. So I'm going to declare an integer. So var a, that's an int equal to 20, for example. And I will have IP or integer pointer. And I'm going to use, again, asterisk in front of the data type, which is integer. And what I will do, and listen carefully, I'm going to store the address of A in IP. So I'm going to say IP is equal to, and I'm going to use the ampersand A. And remember, the ampersand is used, as we said here, to get the address of the variable. Now let's print three different outcomes to the console. The first one is the address of A. That's going to give you the reference to that variable A, basically, right? That's going to be a hexadecimal number. That's the address. Also, the address stored in P, that's going to be exactly the same one because you have stored actually the address of A in IP, in the integer pointer. And finally, we want to get the value of the pointer, and that's by using this asterisk right here, which of course is going to be number 20. Now let's try to run that program. Let me just save and exit. Let's do run main go. And there we go. We have the address of A, this hexadecimal number. You have the address of the integer pointer, which is this number, and the value at IP 20, as we said. Note here, and this is very important, we have stored the address of A in the pointer. That's why both addresses are the same. Also remember that pointers cannot all the time have values. pointers are allowed to have nil value, which indicates that they are not initialized. So you've created a pointer with data type integer, and it doesn't have any value. If you'll try to print that pointer, you're going to get 0. Indeed, we have here the value of PTR is 0. And that's everything that I have in pointers for you. Thank you so much for watching, and I will see you in the next lesson. Hey guys, and welcome back. In this lesson, we're going to study structs or structures in Go. Structs or structures allow you to group different types of data together. So you can have booleans, strings, integers, all in one data type called struct. And this is very useful and ideal, I find it, to represent complex data. Let's say, for example, that we want to track books in a library. We can do that using struct. So to define a struct, we need to use two keywords, type and struct. Let's say that I want to create a struct called book, for example. So that's a book, right? And what's that actually? This is a struct. But the name of the struct should be preceded by the keyword type. And following the struct, we will open curly braces. So let's say we want a title, we want author, we want also the subject, and let's say book ID. All right? But that's not enough because we need to define the data type. So this is a string, this is also string, this is also string, and the book ID, that's going to be an integer naturally. We can also create instances and access the fields using a dot operator. So you can create a struct and think about it like a class in Python. You create a book class in Python and you can instantiate the class by creating different class objects. That's exactly the same thing in Go. So how to do that? Simply by creating that object. So let's call it book1, and I'm going to declare and initialize on the same line. So basically I'm instantiating that book struct by creating that book1 object. So the book here is going to have those fields. The first field is title, and the title here is, let's say for instance, Shawshank Redemption. So that's the first field. I need 3 more, right? So we need the author, the subject, and the book ID. So as far as the author, that's Stephen King. As far as the subject, we can say novel about prisoners. And as far as the book ID, we can give that any number 0, 1, 2, 3. Now let's try to print that book1 object. So I'm going to say format.print println, and we can access any field that we want to access the title field, for example. That's going to be using book1 object dot title. Right? So if you've worked with Python or prototypes in JavaScript, the idea is not new for you. It has just a different name. There it's a class or a prototype, and here it's a struct. And by the way, we have forgot to have the package main, and we also, we want also to import format. And we want to create the main function, our main entry point. I totally forgot to do that, and can do like this. All right, now let's go ahead and try to run our program, and there we go. Title, Shawshank Redemption. We can repeat the same thing by access different fields. So we can say here the author, and that's going to be book1 dot author. Don't forget that the A is capitalized. Just minimize a little bit. All right. And also here we have the subject. The field should be, the field is key sensitive. We need to respect the key sensitive feature of every field in the struct. And here we'll have subject and book ID. All right. And let's get back to our terminal. Let's run that again. And there we go. We have everything here. We have the title, the author, the subject, and the book ID, and they're all not of the same data type. We have 3 strings and 1 integer. So we can add a boolean as well if you want. We can say here red, and that's going to be of data type bool or boolean, right? And we can have this field right here. So red, we can say true. Now we can access that. So red already, and we can access, instead of book ID, that's going to be red. Let's run that one more time. And red already, yes, that's true. Alright guys, so that's everything that I have in Structs for you. Thank you so much for watching, and I will see you in the next lesson. Hey guys, and welcome back. In this lesson, we're going to study slices in Go. The concept of slices is really easy to understand. Slices are more dynamic and more flexible than arrays data type. Simply, a slice can allow you to create sequences that can change in size if you want. So it's more dynamic, as I said, and you can decide the size of, let's say, integers or whatever the characters are. So that gives you more flexibility in the size determination of the sequences that you want. Let's say some integers or any characters in general. So to define a slice, they can be declared by specifying the element type without a fixed length. Be careful, you don't have to put any fixed length here. Let me show you. We're going to use the var keyword, of course, to write the name of the variable that's going to be our slice. And simply you would do open close brackets. You can think of a slice as an array, but it's not an array. It's a slice of the array based on whatever the number of the characters that you're going to determine. And of course, don't forget to enter whatever the data type that you want. So I'm going to leave it simply to int. So here is the declaration of a slice of integers. And what happens after the declaration? Of course, the initialization. So we want to initialize the numbers variable. So numbers here is going to be equal to a method called make. And make is a very interesting one. It's going to create the array of whatever the number of integers that you want to determine inside that slice. So we can keep it like that. Yep. And instead of 0, that's going to be 5. So this way we have initialized numbers, this variable, as a slice with the length of 5. Not only the length of 5, but also the capacity of 5. So that's going basically to hold 5 zeros, not 5 numbers, but 5 zeros. Initialization of slice of integers. So if you're going to print that slice, you're going to have 5 zeros, as I've told you. So that's the length and capacity of that slice. These are 5 zeros reserved in that slice called numbers. We can do things better here just to make it cleaner. This is just for better explanation, but of course we can do this. We can do numbers like that, and make here can actually copy this. And that's going to be the same thing, right? Just here I wanted to, explain to you that first that's going to be the declaration, then the initialization, and I didn't want to make it on one line, but yeah, this of course is the way that I write any Go application using the shorthand. And if the concept of slice is not clear yet, let me talk a little bit more about slicing. So we have something called sub-slicing. We can create new slices that reference parts of an existing slice. So let me do like that. Just I will do like this, comment all those lines out. So let me declare that numbers to variable. That's going to be a slice, and that's going to be again integer. That's going to hold different numbers from 0 to 8. So we'll do 0, 1, 2, 3, 4, 5, 6, 7, and 8. That's enough. All right. So this is the numbers slice. Now we can create different subslices, right? So I can do subslice. That's going to be reference. And now you're going to understand or comprehend better the concept of slice itself. Because what we want to do is we want to take the numbers slice and we want to just have the elements from index 1 to 3. And that means from 1 to 4 not included. And just let me delete this and do like this. All right, here for instance, I want elements from start to index 2. So the first number is going to be with index 0, the second number is with index 1, and the third number is with index 2. Okay, so if you want elements from start to index 2, that means that you need to do till 3, like that. Okay, and also I want the elements from index 4 to the end. That's the way to do it. So let's actually go ahead and print all that, and we'll call those 1, 2, and 3. Okay, right? So take a look now what we will have. Undefined numbers. Oops, I apologize for that, guys. Number 2, number 2, and number 2. And there we go. Let's compile our code again. And there you have it. Subslice 1, 1, 2, 3. So the elements from the start to index 2, that means that 2, 3. And finally, we wanted the elements from index 4 till the end. All right. We can also use methods like append and copy. So append method is going to add elements to a slice, and copy method copies elements from one slice to another. So back again to the numbers example, I have a number slice with empty elements. Now I want to append elements, so I will take the numbers, which is again empty. I'm going to append to it some numbers. So I'm going to use the append method and pass inside the first argument, which is going to be the slice, and then numbers from 0 to 4. So 0, 1, 2, 3, 4. Also, I have a second slice, which is number 1. So number 1 here is equal to, directly the make function or make method. That's going to create a new slice of type integer. And also we have here len numbers, cap numbers multiplied by 2. That simply means that here is the length of numbers 1. It's going to be set to be the same as the length of the original number slice. And this is set to be the same as the length of the original numbers slice. So you have here 0, 1, 2, 3, 4. You will have the same of that length numbers. And finally, you have cap numbers multiplied by 2. And that's simply the capacity of numbers 1 that's going to be set to double the capacity of the number slice. So if we have here 5, that's going to be 10. And finally, we are copying the contents. So the copy method has 2 arguments. The first one is the first slice that you want to copy to, and the second slice, which is the one that you want to copy from. Right? So that's simply it. And I don't need to explain that to you guys. So we're going to print numbers. Okay, that's going to be 0, 1, 2, 3, 4. And also numbers 1, that's also going to be 0, 1, 2, 3, 4. Be careful that here I've just only created an extra space, but that doesn't mean that that's going to display 10 numbers, right? Eventually you can increase it by 5 more, or you can triple it even if you want. But as you're going to copy the exact content of the number slice to numbers 1 slice, you're going to have the exact same numbers. All right, so let's take a look what we have. And there you go, exactly as I told you. So number slice 0, 1, 2, 3, 4, numbers 1 slice after copy 0, 1, 2, 3, 4. Awesome. I wanted just to clarify one thing, maybe I haven't explained it well. Numbers 1 is initialized with the length of 5, but a capacity of 10. So the capacity here is going to give you extra space to work with. The length is always going to be 5. So first, let me show you. If we'll print that, we'll have here 5, the length is 5, of course, but it's empty, 0, 0, 0, 0. And also, if we have increased that to 5, 6, 7, 8, 9, and 10. Let's save that. Let's run that. Okay, you can see here that from 0 to 10, and also, it has copied the exact same length. And if I will uncomment this line and run again, you have here copied from numbers. You will have here numbers1 slice copied from numbers. So that's it, guys. Back to the capacity and the length again. That's very important for you to understand. There is a difference between the length and capacity. The length of a slice is the number of elements that currently stored in that slice. However, the capacity of a slice is the total number of the elements that the slice can hold. Okay? Don't confuse the array that has different elements with the slice. Okay, this is an array and this is a slice. So the capacity of a slice here that indicates the maximum size of the array that the slice can reference. Okay, don't confuse both of them. You have the length and you have the capacity. The length here is 10 or 5 or whatever. The capacity can be the same. So you can make it so if the length is 5 or 10, for example, you can keep it the same as the length. You can keep the capacity the same as the length. Also, we can double them by 2 or by 3 or whatever. And that simply means that we can refer to the array twice or 3 times or 4 times. All right. Hopefully I made that clear for you guys. Maybe the last thing that I wanted to talk about in this slices lesson is nil slices. So sometimes you get a slice that it's declared but not initialized, right? This is a nil slice. It's with a length and capacity of 0 basically. So we have here nil slices. And I'm going to give you a quick example. So let's have, And I'm going to give you a quick example. So let's have var num, just of type int, that's a nil slice, right? The first one that we have declared here, this is also a nil slice, unless we initialize that number slice on a different line. Okay, but for now, this num slice is a null slice. So let me show you. If you will print that, you see here that numbers is an empty slice. Now, if you will check out if num is nil, nil, you want to print out that this is a nil, or this slice is nil, right? Slice is nil. Right? Slice is nil indeed. Alright guys, and that's everything that I have in slices for you today. Thank you so much for watching, and I will see you in the next lesson where we're going to study ranges in Go. Hey guys, and welcome back. Congratulations on making it so far. Today we're going to study ranges in Go. The range keyword in Go is a very powerful tool used in for loops. And it's used to iterate over various data structures like slices, arrays, and we have studied the last time slice, right? And in chapter 12, we have studied arrays as well. So you will be definitely able to follow along in this chapter. But not only in slices and arrays, but also in strings and maps. Think of it as a universal key that opens different types of containers. It's going to let you access their contents very easily. First of all, let me show you if we want to use range with slice and arrays. So let's say that we have number slice that holds numbers from 0 to 8. Now when you iterate over a slice or an array, the range is going to return two values. The first one is the index, and the second one is the element and that index. And I'm going to give you a quick analogy in Python, as a lot of my subscribers and viewers are Python developers. In Python, when you use a loop in a list, for example, you want to loop over a list, you can get both the index and the item, and to do that, you use the enumerate method. Here is exactly the same thing. So here what you would do is you will loop over the numbers, the number slice. So you would say for I and number equal to range numbers, and you will print the I and the number. So let me maximize the console and run our program and take a look at that. Slice item 0 is 0, slice item 1 is 1, and so on. So I just made it more complicated here to make it more interesting, but you can do n is equal to, let's say here, int, and we can do 1, 2, 3, for example. And I would say here for I equal to, like that, range n, and simply I'm going to print the iterator, right? So the array item, that's going to print just the iterator. We can do that definitely. So take a look, you'll have here array item 0, array item 1, array item 2. And if I want to make it as the first example, I can say here is, and yeah, we can do it this way, right? And take a look. That's going to be the same as slice. So we have array item 0, 1, and 2. And why I have a different outcome, array item 0 is 1, because I've started from 1 and not 0, like in the number slice. So I have here a different index. So index 0, index 1, and index 2 for number 1, number 2, and number 3. So that's everything that I have for you in ranges for this lesson. Thank you so much guys for watching, and I will see you in the next lesson where we're going to study maps together. Hey guys, and welcome back. In this lesson we're going to study maps in Go. Maps in Go are a powerful data structure. This data structure pairs unique keys with corresponding values. This actually enables efficient data retrieval by simply knowing the key. Sounds familiar? I bet it is. In Python, we have dictionary. In JavaScript, you have objects, or also map type. If you've programmed in something like Java, you have also hash map. So dictionary, map, hash map, they're all the same thing. It's a set of curly braces with key value pairs. Now, with that out of the way, let's check out our examples. To initialize the map in Go, we can do it by declaring a variable. By default, the map will be nil. If you will leave it like that, like a slice, like we have seen with slice, if you just leave it like that, it's going to be nil. So I'm going to use the keyword var here to declare my variable. That variable is going to be ultimately my map. So my map variable, right? That's going to be followed by the keyword map. Now, map is going to take the data type that you want that map to hold. So you can have a map or a dictionary of integers, should be always integers. Strings should be always strings, and so on. So let's say here that we have a string, and also I want the data type that that map is going to return. So if we'll have input string, we'll have output string as well. Awesome. Now we can initialize the map. A nil map cannot hold values, by the way. So you will leave it empty. So that my map or variable, call it what you want, we will have here our make method. And in the make method, I will pass map, and that map here will have the string, and will return a string or we'll have data type as string as a result. So if you will try to print that, so we'll do print ln, and you will say here my map value is my map. Take a look. If we will print that, you will have here a nil value. Map value is map with empty brackets. All right, so that was very important for you to understand right away, because we're going to advance bit by bit in that tutorial. Awesome. Now let's create and use a map for real. So I'm going to comment those lines out. So let's declare and initialize a map. I'm gonna call it country capital map, and that's going to have string data types inside that map, and it's going also to return string data types. Now you can insert the key value pairs into those dictionaries or maps. So country capital map, it takes France, and I want the result of that to be Paris, right? So string input, string output, integer input, integer output, and so on. So we're going to repeat that for Italy, Japan, and India as well. So that country capital map, I'm going to use each key for that, right? Because we have key value pairs, as we said, we have the country and the capital. The country being the key, the capital being the value, right? So we're going to retrieve the information that we want using the country, which is the key in that map. All right, so let's go ahead and run that. Awesome. So I have here capital of Italy is Rome, capital of Japan is Tokyo, and so on. Where Italy is the key, Rome is the value. And we can also check for the presence of a certain key. So let's say that I want to check out of the presence of the United States, for example. So I'm going to say capital and OK equal to country capital map, and the country, yeah, that's right. But let's say, for instance, USA. Then I will do the checking, and I will say if OK, I'm going to format.println, println capital of USA is then the capital. Else we'll say format.println, and we'll say here simply absent, or not absent, doesn't exist. All right, let's check that out. Does not exist, because indeed the iteration has went through the maps by the keys and didn't find USA. And yeah, we can actually add another one. We can, if we will change it to Washington, right? And I'm not going to change anything else, and we'll run that program one more time. There we go. Capital of USA is Washington. That's awesome. Now I want to show you the delete function. The delete function can be used to remove an entry from a map, for example, if you want. So it's going to take two arguments, basically, the map itself and the key of the entry to be deleted. So I want to delete the capital. I want to delete Paris, for example. So I will need to pass France, which is the key to that capital. So let's try to do that. If we'll do here delete an entry, we can do that simply by invoking that method called delete. That's, as you can see, tab 9 has auto-completed that. So the country capital map, I'm going to leave it as it is, and the country, I'm going to define it to be France. So France is the country that I want to delete, basically. So I will say here format.println, and we can say here entry, or entry of entry for France is deleted. And that's very useful to know if you want to create a to-do list. That's going to be the same thing in the delete functionality. You're going to delete by ID or by key, right? And you want to update the state of that map. So we can say here update the map state, and we can just simply here print a simple message telling to the user that updated map, and we're going to print everything, right? So we're going to iterate through first, so for country in the range of the country capital map, and I'm going to update or print everything after the deletion. So let's go ahead and actually try that out. And there we go. We have here everything. So from India to USA, then we have entry for France is deleted, then updated map, then we have all of the countries without France indeed. All right, guys, so that's everything that I have in maps for you. Thank you so much for watching, and I will see you in the next lesson. Hey guys, and welcome back. We are approaching the end of this course, and I gotta tell you, it was an absolute pleasure doing that for you guys. All right, today's lesson is about recursion. Recursion simply is a technique where a function can call itself to solve smaller instances of a problem. It's very useful for tasks that can be broken down into repetitive sub-problems, if you will. And recursion is similar to Python's recursive functions for problems like traversing trees or calculating sums. In JavaScript, for example, you have functions that simplify complex calculations by breaking them into smaller calls. So that's the main idea of recursion. First of all, the basic structure of recursion has two things: a base case and recursive case. So the base case that stops the recursion to prevent infinite loops. Because imagine that there is a function that it's calling itself again and again and again and again. That's going to enter in an infinite loop. So you have the base case to stop the recursion by preventing the infinite loop. Okay, and the second component of that structure is the recursive case. The recursive case is the heart of the recursion idea, basically that the function calls itself. Now, I'm not going to explain factorial as I've explained it a lot. I'm going to leave just a link, or you will find a card appearing now that will take you to a video just explaining what factorials or factorial function is in mathematics and in programming. So I think this video is going to be very helpful for you. So I'm going to assume that you understand what factorial is. And if you don't know, simply factorial is a function that it's applied on positive numbers, positive integers, and is going to be the product of all positive integers from 1 to that number. So you're going to apply your factorial function to whatever number is. Let's say factorial of 5, factorial of 4, okay? So you can see on the screen, the factorial function, it takes an n, which is the parameter. It's of data type integer, and it will return integer as well. And you will check if the n is equal to 0, you're going to return 1. And that simply means, just to explain to you in mathematics, if you will apply factorial on a number, let's say 5, it's going to be like this. This means 5 factorial. That's going to be 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1, multiplied by 1, and that's essentially going to be 120. Okay? So now, if n is equal to 0, we'll return 1. So why is the factorial of 0 is defined as 1? Simply, it helps in mathematical consistency. Think of it this way. If you have 0 items, there is exactly one way to arrange them, just by doing nothing. That's all. You can think of it this way. So the factorial of 0 is going to be defined as 1. Else, we're going to return the n multiplied by factorial of n minus 1. And that's essentially what I've explained to you here. The factorial of the number, is going to be the product of all of those numbers diminishing till they reach number 1. Now let's get back to our main function and let's print, we can say format.println. We're going to print the factorial, the factorial of 5. So factorial will pass number 5, for example, right? And you can just add this here. Factorial of 5 is like that. Let's open the integrated terminal. Let's just get out and go to recursion lesson and do go run main go. And you'll find that the factorial of 5 is indeed 120. Hey guys, and welcome back. In this lesson, we're going to study typecasting in Go. Typecasting means that you can convert a variable from one data type to another. You can convert a string to an integer, you can convert an integer to a floating point, and so on. So let's go ahead and take a look to a few examples. Let's say that I want to declare a variable called total, for instance. So I will declare, initialize and declare different variables, right? So the first one is called total, and that's of data type integer, and that's going to be equal to 20. I also want to have a variable called items, that's equal to 7. And I want to have the average, and that's going to be of floating point 64, right? So we have total value, we have number of items, and you have here a variable to hold the average. Okay, now we can cast to float 64 for accurate division. To do that, I'm going to say average, and the way to do typecasting is the following. You're going actually to write the type name that you want, so here float 64, and inside parentheses you're going to pass your expression. So in this case you have total, and the same thing is going to be for the other items. So you have for total and items, you want both to be float 64, because actually you have here int and int. But by doing the typecasting, you're going to return the result as floating 64. And let's actually print the result. And it's complaining, and that's fine because they should merge together. But I explicitly want to do that to show you that on one line you have here an average variable that's defined or declared as float 64, and on another line you want to do the typecasting, which is total and items. Awesome. Now let's go ahead and run that. Let me just first get out of the previous lesson, and let's go to 19 typecasting, right? And let's do go run main go. And you can find here that the average is indeed float 64 data type 2.86. Awesome. So that's it in general, guys. This is typecasting, where you can define the data type that you want to be casted to, and in parentheses your expression. Also, you can convert string to integer. This is I was not planning to do this, but yeah, let's have it as a bonus. You can convert string to integer. So converting string to integer, by the way. Let's say that we have a string that's equal to 1, 2, 3, and let's have number and error as well, and that's equal to the strconv conv package, and I'm going to use a method called A2OI, and I'm going to use a method called ATOI, ASCII to integer. Okay, and I'm going to pass the str, which is 1, 2, 3 as a string, right? So that's basically it. We can check out for potential errors. We can say if error is not equal to nil, what I'm gonna do is I'm going to print error converting, and I will show the error itself. So format.printf, and I'm gonna say converted number and the number, right? So let's go ahead and try that out. You can see here that converted number is 123. We didn't have any errors. So if you do like this, for example, now you will have an error. Cannot use stir as string value in argument, of course, because as you have defined that that's a string, because you want a string and not an integer, and the ATOI and the ATOE method has, was confused because it was expecting a string and not an integer. If you want to get that error, you would do here, for instance, nothing. If you would do something like that, you're going to get the same thing, right? You're doing like that, you're going to get the same thing. If we'll get back to a string that can be converted to number, because you might tell me, okay, so this is a string, right? Nothing wrong here. No, it's wrong because you want to convert that to an integer, and ASD are characters. So if we return back here, it's going to convert with no problem. All right, so that's everything that I have in typecasting for you guys. Thank you so much for watching, and I will see you in the next lesson. Hey guys, and welcome back. This lesson is a bit advanced. We're going to discuss interfaces in brief. I'm not going to go into details, but I'm going just to give you the gist of what interfaces are. Now, if you will visit the Go website and you will go on this page, right, tour methods, chapter 9 or page number 9, you're going to find out that they are discussing interfaces actually. So what it says here that an interface type is defined as a set of method signatures. A value of interface type can hold any value that implements those methods. What on earth does that mean? All right, let's get back to our VS Code and let me show you. As the Go website has told us, interfaces define a set of method signatures. That's all. What exactly does that mean? To understand it better, you need to remember structs. To define a struct, you will start by the keyword type, the name of your struct or class, and the keyword struct here. And inside curly braces, you're going to enter your variables. That's that's not very far from what actually an interface is. So you're going to start by the keyword type, and you're going to say here, this is an interface, for instance. And instead of struct, of course, you're going to type interface. That's exactly the same logic. But instead of variables, you're going to have methods here. That's method name 1 and the return type of that method. So return type. We can have more than once. We can have 2, we can have 3. So that's the idea of an interface. Of course, all of that is theoretical. To understand better, let me show you a practical example to grasp the full idea of the interface. This interface is, I'm gonna call it shape with capital S. And I'm going to have here area, and that's going to return it in a form of, or data type float 64. Right? Also, I want to define a struct. So if that's an interface, this is going to be a struct, and I'm gonna call it circle. So you see why I started by showing you struct and interface, because to define both of them, that's very, very similar, same way. And here I'm going to pass the variable, right? So the interface, you pass inside it method, the struct, you pass inside it variables. All right, also I will define another one. So that's going to be a circle struct, just to be precise, and that's going to be a rectangle struct. I'm gonna call this rectangle. And that's also going to return data type float 64, but of course not radius. So I will need 2 different parameters, the width and the height. And after defining my main shape interface and my circle and rectangle structs, I want now to implement the area method for the circle and the rectangle. So how to do that? Simply, just let me add a comment first. Implement area method for circle, the same for rectangle. To implement the area method for the circle, I'm gonna say func c circle. So the c is the object from the circle class or struct. Also the area, so the area is what I want to display. That's the method here defined in my shape interface. So I'm going to use that down. So the area here is going to return float64, of course, and we will return the 3.14, that's pi, or by the way, you can use math.pi, but we'll need to import math up. It has already imported it, awesome. So return math pi multiplied by c.radius and c.radius. All right, so one more time, that's the implementation for the circle struct, taking in consideration the area, which is the main method inside my shape interface, right? Then I want to return pi multiplied by c.radius and c.radius. And I also want to implement the area method for the rectangle. Func r for rectangle, that's the object. And here I will take the area method, and that's float64, of course. Then I will return r.width and multiplied by the r.height. All right, so these are both the area method implementation for the circle shape and rectangle shape. And the way to do that is by creating another function. And that function, I'm gonna call it, let's say, getArea. And I want to have an instantiation of, or an object of, that shape interface, like we have done with the struct or the classes. So that's s for shape as an argument, returning the f or the float64 data type, and inside here I will return s.area. And finally, we will use the getArea function that we've created to calculate or to get the area of any shape, and that's by using our shape interface here above. Yeah, so the main thing you need to know is the shape has or holds inside it a function, and that function can be used to display whatever that's you want to display. So for instance here, the area should return float64. So getArea function here is going to be invoked, passing inside it the circle. Instead of shape here, that's going to be the circle, right? And the circle itself is a function. And that function is returning the pi multiplied by radius, or c.radius, c.radius. And if you will take a look to the execution of our program, you will find that the calculation has been done properly, circle area and rectangle area of data type float64. All right, that's an advanced concept, and as I told you, the similar to it traits in Rust. I haven't created the advanced course in Rust yet. I was not supposed to put interfaces in this course, to be honest. But yeah, I wanted just to give you an advanced look of some of the concepts in Go. And yeah, I think that's everything that I have for you in interfaces. Thank you so much for watching, and I will see you in the last lesson, which is going to be the 21st lesson in this course. And I'm going to show you how to do error handling in Go. Thank you so much, guys, for watching, and I will see you in the next and last lesson. Hey, what's going on, guys, and welcome to the last lesson of the course. I'm really happy to have shared this journey with you all. Let's wrap this course by checking out how to do error handling in Go. Go actually provides a straightforward error handling mechanism using an inbuilt error interface. Go provides a straightforward error handling mechanism using an inbuilt error interface. And this allows functions to return error messages alongside the regular return values. So you can see here on the screen errors, which is number 19 of 26 in total. That's the error page. I'm not really sure if there are other pages for errors or not. So yeah, so that's explanation and another page for exercise. So you can see here that it says that Go programs express error state with error values, as I told you. So that's explanation on your left side, and the code on the right side. You can try to do that. You can try to click on run and see what you will get. So there is an error here and it didn't work. That's the error handling mechanism using the error value. Awesome. So let's go ahead and get back to our code and see what do we mean by the error interface. And you can define the error interface simply by typing type error interface. And inside curly braces, you can type the method that returns the error message as a string. So that's the error message, and I want it in the form of string. And of course, you can return errors from functions. So you can create a function to return you basic error message. We can do that using errors package. There is a package called errors, so we can import it actually. And that errors package this here imported for to create the error messages actually. So that's imported to create error messages. And of course we'll need the format because we're going to print to the console. And also I will need the math package because I'm going to show you an example actually on square root, how to create square root and how to return errors. So for instance, if we have negative input, how to return errors from that using the errors package. All right, awesome. So let's create a function. I'm gonna call it, but just let's make sure that we're outside of the main. Oh, I didn't actually write the main package. So let's write the main package. So this function, I'm gonna call it sqrt, so square root. So square root is going to calculate the square root. So I will need an input, a parameter. So that's going to be the value, and I want it to be float 64 data type. And also I want to return float 64 data type as an output and an error if there is any error. I'm going to check out if the value is less than 0, let's say. I want to return an error for any negative input, right? So that's the idea. So I'm going to return 0 here, and errors, that's the errors package that I'm going, that I've, imported, and that's a method called new, or let's make it negative number passed to square root. Otherwise, I want to return the square root and a nil error. So I'm going to return using the math package dot square root, and I will return the value here and no errors. That's why I've defined here in my function that I want the result to be float 64 and error, whether there is an error or not. If there is no error, I'm going to just simply return nil error. Then let's get back to the main function down here, and we're going to just test the square root function with a negative, just to show you, with a negative value first. So the way to do that actually is by just defining result and error to two different variables, square root -1 or minus whatever. And why I have done that? Because again, as we have defined in our parameters, I will need the output to be float 64 and error. So I'm going to check out if the error is not equal to nil. In that case, I will print the error message if an error occurred. So I'm gonna take format package.println, and I will print that error. So the error here is going to be the message that we've created here, negative number past the square root, right? Because error is not equal to nil, which means error exists. So next in my control flow, I will say else, and I will simply print the result. All right, so let's do that again, and we have here negative number passed to square root, which means that indeed there is an error because we have -5. Okay, let's get back to our code, and let's see if we will just test the square root function for a valid value. So let's just do here, just do like that. We're going to test, I don't know why it's like this, just make spaces. So, okay, so I'm going to test the square root function with a valid value. So that's going to be exactly the same logic, result and error. That's equal to, equal to square root, and here we're going to pass 5. And again, that's going to be exactly the same code. And now let's go ahead and try our program to see if we'll get a result. And indeed, we got a proper number, a proper floating point number, which is the square root of number 5. And if we'll get back to the errors page of Go, so it starts by package main, import, format, and time. Then you have here the type. So here, for example, this is a field. This is a field to store the time when the error occurred, which is very smart, by the way. And the second field is used to store a message that describes the error. Then implementing the error method for myError to satisfy the error interface. This is a built-in interface provided by the Go error package, and that's being returned in a string format. So we will return format.sprintf at, so you will need the time and the message itself. So here e.when and e.what. Then down here below, you have a function that simulates an error occurring and returns my error instance. So that's actually returning a pointer to new my error with the current time and the message. Okay. Next you have time.now. So that sets when to the current time, and it didn't work, sets what to the error message. And finally, you should go to the main function. There you go. So in the main function, it calls the run function and checks for errors. So if error is not equal to nil, we're going to print the error itself. All right, so we can check out what we will get. We tried it before, but yeah. So you have here the time, you have here the time and the message, the when and the what. And with that last bit of explanation, we are done with our Go course for beginners. Thank you so much for watching. I appreciate all of the positivity, the comments, the feedback. Even if there is any criticism, it's always being constructive. Thank you so much, guys, for sticking around. I appreciate it all. And I will see you in the next courses. Till then, stay safe and be well. See you later, guys. So if you have mental weakness, you need to toughen up, man up. Just hit the gym, man. Train your body. Cut out victim mentality. Handle problems like a man. And if something's wrong, fix it. If you can't, move on. Stop complaining. Complaining will not do anything.
So toughen up, man up, fix your problems, stop being a victim, play the role of the victim. Or if you're a victim, just don't talk too much about it. Being a victim in the society is very common, but the reaction to that, what separates boys from men. Social media, control it, or it's going to control you. You're going to be a slave to social media. Don't do that. Use it for business or learning, not mindless scrolling. Yeah, I'm talking to you. Don't be in your bed at 1 o'clock, 2 o'clock in the morning, just scrolling around reels or whatever. It's not going to do you any good.